doing this in third period and fourth period, so I'm going to write on sticky notes. So I'm not writing directly on my answer key, but you are not going to write on sticky notes. You're going to write directly on your assignment because you are not in third and fourth period. You are only in one period. So you only have to do this one time. Okay. So on this paper, somewhere across the top, it doesn't matter where, somewhere on the paper, we're going to write how we know if something is a factor of a number. How do you know if something is a factor of a number? So we're ignoring this for a second. We're thinking back to like when we first learned what factors were, maybe middle school, maybe as low as like 6th grade or something. How do you know if something's a factor? Like, is 2 a factor of 12? Is 5 a factor of 12? How do you know? If it's divisible, and let's go a little bit deeper into that, without a remainder. So if it divides evenly, that's how we know that something is a factor. Okay, so we're going to write that on the sheet, just somewhere, maybe across the top somewhere, maybe in the margin on the side. We're just going to remind ourselves what a factor is, okay? So I'm going to say factor, and I'm going to say a number is a factor of another number. If it divides into that number evenly. Okay. So a number is a factor of another number if it divides into that number evenly. Okay? So we're going to use a number. Again, you're just writing this in the margin. Okay? So I'm going to think of the number 36. Okay? And let's think of some factors of 36. What are numbers that divide into 36 evenly? 6, 12, 3, 2, 1, 36, 18, 9, 4, okay. And then we have things that are called prime factors. Do you guys remember the difference between like prime factor versus a number that's not a prime factor? So 12 would not be a prime factor because 12 can be like factored itself, right? Whereas 3 would be considered a prime factor. Do you guys remember that kind of from back in the day? Okay, so that's kind of your example. So we can do the same thing with polynomials. So we can look at the problem, and if it doesn't have a remainder, then it's a factor. And if it does have a remainder, it is not a factor. Does that make sense? Okay, so if we look at problem A, there's a remainder of -6. So our conclusion about that problem is that x minus 1 is not a factor of x to the 4th plus 4x to the 3rd plus x squared minus 7x minus 5. That's our conclusion. There is a remainder. It's not a factor. Does that make sense? It did not divide evenly, so it's not a factor. Okay? What conclusion? Yeah. It wouldn't be 6x to the -1 because it's x minus 1 on the bottom. You'd be close. You'd be very close, but not quite. Yeah. It'd be approximately, but not exactly. Yeah. It'd be 6 parentheses x minus 1 to the -1. Yeah. All right, if we look at G, is x plus 8 a factor of 9x to the 4th plus 69x to the 3rd minus 20x squared plus 33x plus 2? No, it is not. Okay, let's turn the page. If we look at D, is x plus 8 a factor of x to the fourth plus x to the third minus 2x squared minus 73x plus 59? No. Okay, let's look at L. Is x plus 8 a factor of x to the third minus 2x squared minus 76x plus 32? Yes. Okay, so we're going to write on this one. We're going to say, I'm going to do it on a sticky note. I'm going to write this sentence out. I'm going to say x plus 8 is a factor of x to the third minus 2x squared minus 76x plus 32. Okay? And then if you think you might not remember why, you can feel free to write the next part. If you think you'll remember it, then you don't need to, but if you think you might forget why, you can say because x to the third minus 2x squared minus 76x plus 32 divided by x plus 8 has a remainder of 0. Okay. So it is a factor because it has a remainder of 0. Make sense? Okay. What I want you to do is I want you to take a moment with your colored pen and go through the rest of the assignment and find all of the factors, and you're going to write that first part. Blah, blah, blah is a factor of blah, 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 but only for the problems where there are factors. So what are you specifically looking for? You're looking for your remainders of 0. Okay? You're looking for your remainders of 0. Okay. How are you guys doing? Pretty good? So our first one was letter L. What was the next one? E. What was the one after that? B. Okay. What was the one after that? J. Okay. What was the one after that? K. And then H. Okay. Yes. Marvelous. Okay. So we're making a pile. And in the pile, we're putting our activity. And then we're also putting our worksheet. What do we notice about the worksheet? All four of them. Yeah. So if we look at the worksheet, the activity was kind of like 3 and 2. Those are kind of what our factors are like for the activity. And then the worksheet would be kind of like 12. Because the worksheet, you were dividing by a whole quadratic, which probably had 2 factors involved. So for the activity, you were dividing by 1 factor. And then with the worksheet, you were dividing by a quadratic, which was possibly made up of 2 factors, because you were dividing by trinomials for most of them. Does that make sense? Okay. All right, so go ahead and make your piles. We're putting all our papers in the piles. All right, so I kind of told you guys that for whatever reason, the polynomial long division tends to be heavily tested on the EOC. The stuff that we're doing today is synthetic division and also something called the remainder theorem. This also tends to be on the EOC quite a bit. So you want to make sure that today you're asking questions, you are mentally engaged, you're making sense of things, because we can definitely say without a doubt this will be on the EOC, and it won't just be on the EOC once or twice, it will probably be on the EOC several times. Okay, so I just want to prepare you guys for this. That said, we're going to cover it enough that these will probably be questions that you'll be decent at by the time we get to the EOC, but some of the questions we go over today are not the most comfortable thing in the world. Some of them will make you want to, like, you know, high five somebody in the face with a chair. It's one of my favorite sayings, but sometimes that's how it will make you feel. Okay? All right, so let's just make sure that we kind of understood the synthetic division from yesterday. So how many examples did we do? 2? 3? So we're on example 4? Okay. Okay, we'll call this example 3 because this is actual with numbers. So we're doing m to the third minus 5m squared minus 11m minus 8 divided by m plus 1. So it would be dependent on the instructions, kind of. So if the instructions were not given to you, anytime what you're dividing by looks like this, synthetic division is fair game. So if you're dividing it by something simple, then you go, ooh, synthetic division. And then anytime you're dividing by something like on the worksheet yesterday, where it starts off with like an m squared, where it starts off with a 5m or something, anytime it's a little bit more complicated over here, you got like, oh, I gotta do long division. So all the problems we did yesterday in the activity, every single one of them, you could have done synthetic division with. Could have. Now, the reason that I didn't let you guys do that is because if I'd let you do synthetic division from the start, none of you guys would have done long division. I could not have convinced you to do that method if I taught it to you first. Does that make sense? So I teach you, now technically synthetic division is not part of the curriculum. Like, we're not even supposed to teach it, but who in their right mind would not teach that when it's so much easier? Like, let me teach it to you guys because it's a time saver. You know what I mean? So, yeah, so if I was doing my job correctly, I would say polynomial long division all day, every day for every single problem. In theory, that's what we should be doing. Polynomial long division always works, but synthetic division works for these. Does that make sense? Okay. All right, so when we look at this one, we're going to say m equals -1, perfect. Okay. And when I look at this, are they in decreasing order? Is it missing anything? Okay, so we're good. So I'm going to put -1 in the little box. Okay. And then what should I be writing? But not m cubed. I write 1. I write the coefficient. So I write 1, -5, -11, -8. Okay. So the first thing is that number's going to go down. Okay. All right. So let's go ahead and start the problem. So we've got 1, and then what do I do? 1 times -1 is -1. We add them together, and we get -6. And then we get 6. You're good. It was a typo. 6 and 7 are very close together, so it's an easy typo. You know what I'm saying? Okay. -11 plus 6, -5. And then -5 times -1 is 5. And then we'll add those together. -3. Okay. So if that was an m to the third, and we've done division, m to the third divided by m would be m squared. And then we're going to drop it down by 1. So m squared, m, no m. And then there's our remainder, so this is going to be our fraction. So we're going to have m squared minus 6m minus 5 minus 3 over m plus 1. Now, we had a remainder, so what's our conclusion about m plus 1? Is it a factor or is it not a factor? Is not a factor. So I'm going to say, based on this, m plus 1 is not a factor of m to the third minus 5m squared minus 11m minus 8. Yes.
If you have us say something's a factor or not, could you just say is a factor or is not a factor, or do you always want us to say like
I'm
not a
doing
factor?
this at first so that you know exactly what I mean. And then eventually, if we want to start to drop it because we understand exactly what we're saying, that's fine. Yeah. Because I think when I've taught it before, students would say, is a factor, is not a factor. And I'd say, what do I mean? And they'd be like, I don't know, but it's not a factor. Exactly. They'd say true or false. And then I'd be like, of what? I don't know, but it's true. So memorizing what the answer means and knowing what that answer means are two very different things. So I want us to write this out so we know exactly what we're saying first. And then after we've done that a few times, then we can start to drop it. Yeah, good question. Okay, let's do another example. This is going to be example 4. 3n to the third minus 6n squared plus 6 divided by n minus 2. Okay, so what does n equal? N equals 2. Okay, so we're going to put a 2 in the box. And then what do we write? Very good. So why did we have to put the 0 there? Yeah, there was no plane n term, so we have to put a 0n in there. Okay? All right, so 3 times 2 is 6. We add those together, we get 0. 0 times 2, 0. We add those together, we get 0. 0 times 2 is 0. We add those together, we get 6. Okay, so 3n to the third divided by n to the third is going to drop down to n squared. So this n right here is going to be an n squared. And then we just go down by 1. So n squared, n, no n, and then our fraction. So we have 3n squared. You can write those if you want to, but common practice is to leave them out because they're zeros, plus 6 over n minus 2. I know it's tempting to reduce it because of the 6 and the 2, but if you reduce it, you kill a puppy. We don't like to kill puppies. They're very cute. Most of them are very cute. Some of them, not all of them. I'm sure we could find an ugly puppy. I'm sure we could. Most of them are cute, though. Okay? So... So, based on the remainder, what conclusion can we make about n minus 2? It is not a factor. So I can say n minus 2 is not a factor of 3n to the third minus 6n squared plus 6. Okay? And then here's the answer. All right, so I'm going to hand out a sheet. We still have one more problem to do in our notes, but I'm going to hand out the sheet first. And to start up with, you are going to do 1 through 4 on the sheet. Okay? 1 through 4. All right. The next thing we are doing is called the remainder theorem. Remainder theorem. It still uses synthetic division, so we are not completely switching gears. We're just using like a nuance of synthetic division, which is called the remainder theorem. Guess what it has to do with? The remainder. Yeah, okay. So it still has to do with synthetic division, it's just using the remainder, okay? So before we learn about it, we have to see what it's used for, okay? So we are going to do an example problem, and you're going to see one way that it can be used, and then the rest of this packet is seeing other ways that it can be used, because the EOC was very good at like, let's use it in this weird little way, let's use it in this other weird little way, let's use it in this other weird little way, and I was like, dang, EOC, you're really good at that. Let me steal all those problems, but put other numbers. Yes?
Since the common EOC, like, do you see some stuff similar, like on the ACT or something?
These are great questions. I'm gonna be honest with you. I took the ACT and the SAT when I was in high school, X number of years ago. I'm not telling you. And then I've helped kids study for it maybe twice since then. So I am way more familiar with the EOC than I am with the ACT and the SAT. So I am not a great person to ask. I don't know that this would be stressed on those tests. I don't know how, if there's a breakdown of like which standards they put on those tests versus which they don't. The questions that were on the EOC, they were very, very good multiple choice questions. So I wouldn't be surprised if something like that, but I have no idea because what I know the best is the EOC. Um, it is on my list to get some ACT and SAT materials to start to incorporate into my classes since I teach you guys those topics. But honestly, I'm not all that familiar with exactly what's on there. Yeah. Yeah. Oh, yeah, yeah. So we do that in this class. There was what? What did you say? Uh-huh. Yeah. And these, so the questions that they ask in relation to this are a little bit more conceptual as opposed to just do it. So, and I think that the last time I helped students, like when I was tutoring and I helped students study for the SAT, they seem to be going a little bit more away from just can you do the skill into do you understand this? And that's what these questions are kind of doing is like, do you understand how this could be used in this situation? Which is kind of what we're practicing today, actually. So I think today the practice is kind of interesting. If you look at the packet, we're actually not doing a ton of problems. It only goes to 10 problems. There's a maze that does more, but anyway, we're going to get into some interesting problems today that we will see on the EOC, and then maybe somebody remind me again, keep reminding me, because I do want to get some SAT and ACT study questions to start putting into assignments so you guys can start to see those so that you won't be a surprise when you get there. Yes? Yeah, ask him does he do math tutoring? Tell him that your teacher wants recommendations of what books seem to be representative of questions so that I know, yeah, just which ones should I get so that I can steal the questions to put into my worksheets and stuff. Yeah, yeah, yeah. Ask him for ones that are like the most applicable to like the recent tests so that I can get like the good stuff that's like current. Perfect. That'd be great. Thank you. All right. So we're going to find f of 6 if f of x is negative 4x to the third plus 29x squared minus 28x minus 8. We're not going to use calculators, so put your calculators away and then see what you can do with this problem. So find f of 6 if f of x equals negative 4x to the third plus 29x squared minus 28x minus 8. F of 6. What does f of 6 mean? Yeah. Yeah, so it means plug in 6. Plug in 6, tell us what it equals. Okay. But don't do it with a calculator, do it by hand. Is this reminding you guys of like your old multiplication skills?
It's reminding me of like the fiery depths of hell.
Did you say fiery depths of hell? Don't cheat and look at my answers. It maybe makes you realize that you're a little bit rusty on some of that older math. No. No. Miss Rice, could you teach me what my third grade teacher tried to teach me and my calculator made me forget? What if we just cheated real fast?
What did you get as your final answer? Can you tell me that?
It's a secret.
I got a really big number.
I'll tell you if you give me $20.
I could buy like 3,000
Yeah. My Venmo is... It's a very nice number. Huh? It is. All right, how many more minutes do we want? Does it make you feel competitive against your own brain? I can do this, brain! Brain!
It's more telling my brain, it's like, my brain is making itself
Like, I don't mind it in the high school level now. But
Yeah.
I hated it.
Yeah. Yeah.
is the next quiz calculator inactive? And I didn't know if that.
Well, our last test was supposed to be partially active and partially inactive, but then we had a shortened period, so I just made the whole thing active. So. All right. The answer is...
Don't tell me.
So why are you torturing us and not letting us use the calculator?
I'm just making sounds. It was very funny when I made a sound that you guys didn't expect, and you were like, wait, did I get it wrong?
I got 71 my first time.
How?
I got 100. I accidentally, instead of multiplying 6 by 36, I multiplied it by 3 by 36.
Yeah, PEMDAS is real important. All right. Anyone who's really confident in their answer, what do we think? 4. The answer is 4. 4. All right. So, I mean, it's real close. It's real close. Yeah. I would give you an oh bless her heart for that one. All right. Now, I'm going to show you something that is very cool, okay? So what we're going to do is we're going to say, okay, this is a 6, so I'm going to put a 6 in the box. And then this is the function, so I'm going to put a -4, a 29, a -28, -8. And this is called the remainder theorem, so I'm going to circle the remainder because I think it's going to be special. Okay, are you ready? So we drop down the -4, and then we do -4 times 6, and what do we get? Okay. 29 minus 24 is 5 times 6 is -28 plus 30. 2 times 6 is -8 plus 12 is 4. Okay, which way was easier? This one is easier. So, if you do not have a calculator and you need to plug a number in, do not do this. Oh no. Oh no. Do not do this. Use the remainder theorem. It is, so you wouldn't do this on the EOC. On the EOC, you just plug it straight in. Okay, but this is an alternate method, okay? Now, here's the other thing we're going to write. Here's the other thing we're going to write. We're going to say, okay, so something that's kind of interesting about this as well is that if we were to take, I'm running out of room, sorry, let me start a new page here, is that based on this problem as well, we know another thing about this, is that if we were to do -4x to the third plus 29x squared minus 28x minus 8, and we were to divide it by x minus 6. See how I changed the sign? Because this was a positive 6 in the box, so it must have been a -6 in the factor. I would say that this is not a factor. Would you guys agree? It is not a factor, and that when I divide it, I'm going to get a remainder of 4. Does that make sense? Okay. When I divide, I get -4x squared plus 5x plus 2 plus 4 over x minus 6. So this process, it tells me a few things about the problem. It tells me that x minus 6 is not a factor of that problem. And it tells me that if I was to plug in a positive 6, I would get a 4 as an output. It tells me two things, okay? So it's valuable information regardless of how I use it. I could do polynomial long division and learn the same thing. Do I want to do polynomial long division? Probably not, because that's more long and drawn out. Synthetic division is faster. So I would do synthetic division. But polynomial long division would give me the same information. It would still give me this answer. It would still give me a remainder of 4. Does that make sense? Okay. So let's get that packet back in front of us. And what I would like you to do is I would like you to use the remainder theorem and no calculator and the remainder theorem to figure out what f of 3 is. Now be careful because this jumps straight from x to the third to just x. So be careful there. So use the remainder theorem to figure out what f of 3 is. We were not using calculators.
have several comments. Do you want just the remainder, or do you want the like?
You could say f of 3 equals that number. All right, what did you guys get? Yeah. We get it okay without a calculator?
I did that at first, and then I thought, oh, I need to plug into the.
Yeah, and the only reason you can't, it's going to give you the right answer. The only reason you can't is because the instructions said use what you know about the remainder theorem. And this is not the remainder theorem. This is evaluating.
No, I know, but then
Yeah.
I took the number. I don't know. I didn't finish solving it because I did it.
Yeah. So they're going to get us the same answer, right? But this matches the instructions, and this does not. Does that make sense? They accomplish the same purpose, but one of them goes with the instructions of use the remainder theorem to do this problem. The other one is solving the problem, but not the way they asked. Does that make sense?
Well, I was going to do it like with the remainder theorem. Just plug in the numbers after the 3 was plugged in.
That's fine.
So like at top it's 3, negative 30, 0, or no, 3, 0, negative 30, negative whatever, 3 times 24. Would that still be right or no?
So you wouldn't plug in 3 first and then do it. You would just do it this way. Yeah. Okay. Number 6, they're starting to get a little bit more complicated. Okay. So let's look at the next problem and let's translate it. Okay. So they're saying if k is a constant, what is the smallest value of k such that the polynomial is divisible by x minus 1. I am already not feeling comfortable with this problem, so I'm going to rewrite it so it looks a little bit more similar to the other problems I've seen, okay? So I'm just going to write it as k squared x to the third minus 7kx minus 18 divided by x minus 1. That they're telling me that I've got this bigger piece, it's divisible by x minus 1. Does that make sense? Could we see how I could get that from the problem? Okay. We're using the remainder theorem, right? So that means we're going to be taking this term right here, and so that means we're going to say x equals 1. Would you guys agree with that? And they told us it is divisible by x minus 1. If it's divisible by that, what does that mean? It's a factor, and the remainder is 0. Okay? So I'm going to write that. It's a factor, and the remainder is 0. Okay. So this means that we can set up the problem. If we did synthetic division, we would have 1 in here, and we would have our coefficients would be k squared, negative 7k, negative 18. See how I wrote all my coefficients?
K squared x cubed minus 7kx.
Oh, thank you. Okay. And then my remainder is 0. You guys agree with that? Okay. So just like up here, we have two forms of this, right? We have, and they are equivalent, right? We have f of 3 equals the synthetic division version, and we have f of 3 equals the evaluation version, just like we did in our notes. We can do it this way. We can plug in 6 this way and get an answer. Or we can do synthetic division, plug in 6 this way and get an answer. The remainder theorem, you can get an answer both ways and it's the same answer, okay? So if you are looking at the problem this way and it feels like nonsense, try it the other way, okay? So this way is saying I'm going to plug in 1 and I'm going to get 0 as an answer. And this feels weird because we've never had variables in the problem right there before. So I'm going to say, let's not do it this way because this feels confusing. Let's try it the other way. Okay? So we're going to take this way over here. We're going to plug 1 in for x. And we know that when we plug 1 in for x, the answer is going to be 0. Does that make sense? Because the remainder is 0. So we know whatever we plug in, the remainder is the answer. Does that make sense to everyone? Whatever we plug in, the remainder is the answer. Alex, does that answer your question? Okay, so because there's always two ways of doing the problem. There's always synthetic division, and there's always evaluating, and they give you the same answer, they're just two ways of doing it. Yes?
Yeah, I solved the synthetic problem with variables and got k squared minus 7k minus 18 is equal to 0.
You did it with the synthetic and it worked out fine?
Yeah, so you drop down k squared.
I honestly didn't even try it. Well, give us a second. I honestly didn't even try it that way because I looked at it and went, ugh. But I tried it the other way, and to me it looked nicer. Give us a second, and we'll see, okay? So if you do it this evaluating way, plug in 1, so we'll have k squared times 1 minus 7k times 1 minus 18, and it equals 0. So see, I plugged in 1, and 0 is my answer. You guys see that? Okay, so when I simplify that, what do I get? Yeah. And Alex, I'm going to bet this is the same thing you got.
Well,
Yes, that's the same thing you got. Okay. Uh-huh.
So basically, you drop down the k, you add the 0 to k squared, you add the 0 to k squared, you add minus 7k to k squared, so you get k squared minus 7k.
Uh-huh.
And then you add...
So it still gives you the same answer when you do it with synthetic. Okay. Okay, so Alex was just saying that you could do synthetic, even though it looked uncomfortable, you actually get the same answer, is what he was saying. Okay, so how do we factor this? Because the whole problem is just saying solve for k. And when you solve for k, we know quadratics give us two answers, and they want the smallest one. The smallest one is the answer they're going for. So what do we do now? Yeah, so we look for our two numbers, right? So we're finding two numbers that multiply to negative 18, but add to negative 7. Two numbers that multiply to negative 18, but add to negative 7. Negative 9 and 2. And so when we solve those, what do we get? Negative 2 and 9. And so which of those is smaller? Negative 2. Okay, so even though these problems look completely different, we actually have the same methodology for solving them. So we said there are two ways to do this. We have the synthetic division way, we have the evaluating way. There are two ways to do this. We have the synthetic division way, we have the evaluating way. With this one, the remainder was the answer because they said, tell us what happens when you plug in 3. The remainder you get is the answer. Here, the remainder wasn't the answer, but it was a huge clue in the problem. They said, this is divisible by x minus 1, and as soon as you read that, you say, oh, if it's divisible by x minus 1, the remainder has to be 0. And that was essential knowledge for the problem. Does that make sense? You had to know that for the problem. Okay. You could do the quadratic formula, you just have to be really careful. So you might have made a little typo, a little mistake somewhere in the quadratic formula, but the quadratic formula would solve it. Yeah. Okay, let's turn the page. So this is another type of problem. And I want you guys to see if you guys can figure this out. So I want you guys to remember there's going to be 2 ways to approach this problem. You can do it thinking in terms of synthetic division. You can do it thinking in terms of evaluating, because remember, they're the same thing. Okay? So I want you guys to think about setting up the problem this way and this way. Okay? Think about their parallel ways, like parallel universes. Their parallel ways of setting up the problem, and doing it kind of side by side can help you understand how the problem works, okay? So I want you guys to do your best in your groups to come up with how could you solve this problem. This graph over here represents f of x, okay? So instead of having a function written out, x to the third, x squared, blah, 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 as that divided by x minus 3, we have a picture, a graph picture divided by x minus 3. So write as much as you can. I'm going to give you guys some time to talk about it, think about it, get as much as you can written out, and then we'll come together and we'll say whatever it is that we figured out. Okay? All right, go ahead and get started, see what you can get. I would start off by saying f of x is being divided by x minus 3, right? That's how I would start the problem. Normally, this would be a whole lot more complicated because normally I would have like a whole function written out here. But this time I don't. I've got a picture. So that means I don't have all my coefficients, I don't have all my exponents, I don't have all the stuff I normally do. But I still have this part, so I do know x equals 3. That makes sense? Okay, so when I do it the 2 different ways, I know 3 ends up with a box, and then like all my coefficients go here, and then over here, I know that this is the answer. Does that make sense? But because I don't have all my coefficients, I can't do the problem this way. So this is out. I can't do it. So then I have to go over here and I have to do the other method for doing the problem. The other method for doing the problem is taking this part right here, whatever this function is, taking this and plugging the number in. So I would take this function and I would plug in 3. Now, I don't have an equation to plug 3 into, but I do have a picture. Does that make sense? So what I want to do is I want to take the picture, I'm going to find an x value of 3, and I'm going to go up and find the corresponding y value. It's that point right there. This point right here is 3, 5. Does that make sense? And so that's what everyone was noticing. That's why they were saying, oh, is it 5? Because they were noticing that 3, 5 is the point on the graph. Does that make sense? Tricky, huh? It's a wild problem. Okay. Yeah. All right. So if you guys look at number 8, does everyone, when you guys look at number 8, now that we've done a couple, when you start to read this one, do you mentally have an idea of how you could start just the first sentence of number 8? It says you've got the problem, and you have the remainder when it's divided is -8. So think through what you have. we have x to the third minus 2x squared plus 13x plus k divided by x plus 1, and the remainder is negative 8. So we want to find that k value, right? And we have a remainder of negative 8. So we always have the two ways of doing the problem, right? With the remainder theorem, we always have the two ways of doing the problem. We can do it with the synthetic division. We can do it with the evaluating. We got the two ways, okay? Depending on, calculator usage, if we can use a calculator or not, which way is easier. So with this one, I'm going to say x is what? Negative 1. So I've got negative 1 in the box. I've got 1, negative 2, 13, and k. And my remainder is negative 8. So this is the synthetic division way of using the remainder theorem. That's one way of doing the problem. Or I could take the negative 1, and I could say negative 1 to the third minus 2 times negative 1 squared plus 13 times negative 1 plus k equals negative 8. That's the other way of doing the problem. So see how there's always two ways? Synthetic division, evaluating. For every problem, when you use the remainder theorem, there's always two ways to do the problem. You can plug the number in, get the answer, or you can do synthetic division and say that number is the remainder. So this is a two-part problem. To do the first part of the problem, our goal is to figure out what that k value is. Don't give the answer away. Come on, man. Okay? So you can choose whichever way you want to do the answer. Whichever way you want to do it is fine. You can do the synthetic division way, or you can do the evaluation way. Does that make sense? So once you have the k value in there, you set the problem up again, but this time you're dividing by x minus 2, so you're going to have a positive 2 in the box, or you're going to be plugging in a positive 2, and instead of having a k, you're going to have whatever that k is you solved for, and then it says once you have that 2 plugged in, once you have that k plugged in, what is your remainder? So then you're solving for the remainder the second time. Uh-huh. The second time. Yep. Mm-hmm. Mm-hmm. For number 9, when it says that you have these factors, what are the remainders if these are your factors? The remainders are 0. Okay?